Good afternoon, everyone. Hello. Energy. The students who are sitting here, they are more energetic. Huh? So you are having a more advantage than this student because you are eating simultaneously by sitting at home. Say loudly. Everyone should unmute and say loudly. Good afternoon.
Good afternoon, sir.
Not you. Other group. We can say offline group and online group. Online group, say good afternoon.
Good afternoon, sir.
Everyone, please unmute. Why you are making a mute? I don't know. Say once again. Good afternoon.
Good afternoon.
Good afternoon. Good afternoon, sir.
Energy down. Okay. Anyway, last lecture we have covered the two important derivations. That is length of open wheel drive and the length of cross wheel drive. Though that derivation will not be asked in the examination, but MCQs can be prepared on those two derivations. Multi-choice questions can be prepared on those two derivations. At that time, you should be able to answer. Okay, guys, I'm not asking derivation. No. You might have observed in your CET examination. MCQs are based on the formulas. Rotational motion. Have you studied rotational motion? In that, they ask the MCQs on the formulas. Mass moment of inertia, then radius of gyration. So they ask only formulas. Okay, so they will give the circular disc. What is the moment of inertia? 5/4, 64, something, the formula. So MCQ type will be asked on the derivation part also. That is also possible. Now, next part is velocity ratio of the compound wheel drive. Please put the heading. Velocity ratio for the compound wheel drive. I'm also not visible. So please put the heading. Velocity ratio of compound wheel drive. So in the open wheel drive, we have seen there are two pulleys. One is driving pulley and second is driven pulley. Okay, then later on we discuss the compound wheel drive. Right. Whenever you want to obtain the high speed ratio, we are preferring this compound wheel drive. Okay, and the shafts are arranged parallel to each other. If this is the case, then we are using compound wheel drive. Now, for this compound wheel drive, what is the speed ratio? What is the velocity ratio that we have to determine? Okay, to determine the velocity ratio for the compound wheel drive, we have discussed yesterday one case, speed ratio or the velocity ratio for open wheel drive arrangement. What is that relation? Correlation of local relation between speed and diameter. I think you are noted. N2 by N1 is equal to D1 by D2. So that relation we have studied. N1 is the speed of driving pulley. D1 is the diameter of driving pulley. D2 is the diameter of driven pulley. N2 is the speed of a driven pulley. So driven speed divided by driving speed is equal to diameter ratio. Diameter of driving pulley divided by diameter of driven pulley. So that equation we have obtained yesterday only. So similarly, that theory will apply for the compound wheel drive. Now, in case of compound wheel drive, if you see the construction or the arrangement, there is a number one, we can say as number one driver, number two, so driven. On the same shaft, again one more pulley is there, again driver, then fourth one, driven pulley. So there are four pulleys here and two arrangements. Let us, for understanding purpose, we'll separate it. First arrangement, 1 and 2. Second arrangement, third pulley and fourth pulley. Okay. For this case, we have to determine the velocity ratio. Okay. Now, you have to draw this construction. arrangement. Draw this arrangement. झालं. झालं. Now in this velocity ratio for the compound belt drive, as there are two arrangements we have considered for the calculation of speed ratio. Okay, the speed ratio nothing but speed of a driven pulley divided by speed of a driving pulley. That we have to determine. Now here our interest to calculate the overall speed ratio for the entire arrangement. When I say overall means what? We are combining these two arrangements. Okay, we are combining these two arrangements. So in this case, there are 4 pulleys. So how the ratio can be mentioned? How ratio can be written? N4 by N1. बरोबर. तुम्ही जसं ओपन बेल ड्राइव मध्ये म्हटला की N2 by N1, that is speed of a driven divided by speed of a driving. Similar here you can apply here now. There are 4 pulleys. So first is a driver pulley and last is a driven pulley. That is pulley number 4 is a driven pulley. So how the ratio can be written? N4 by N1. So that we have to determine. Okay. To get that ratio, we will go separately. Okay. Write down. Velocity ratio for first belt drive arrangement. Velocity ratio for first belt drive arrangement. Velocity ratio for first belt drive arrangement. हाँ, काय ना इक्वेशन मग समजा आता एक पहिला सेक्शन घेऊया आपण, पहिले अरेंजमेंट घेऊया. That is what? N2 by N1 is equal to D1 by D2. The D1 is the diameter of driving pulley and D2 is the diameter of driven pulley. So N2 by N1 is equal to D1 by D2. Say equation number 1. Well, equation number 1 there. Similarly, get the equation for second arrangement. कोण सांगेल? Second arrangement, where you will consider pulley number 3rd as a driver and pulley number 4 as a driven. So how will write the speed ratio equation? N4 N3 is equal to D3 divided by D4. Equation number 2. Now to get the overall speed ratio, we will combine this. Or we consider it in series. So from equation 1 and 2, from equation 1 and 2, we can write as so make the equation of 1 and 2 multiplied. Left term LHS terms ची multiplication and RHS ची multiplication. Equation 1 and 2 चं काय करायचं? Multiplication करायचं. LHS ला RHS. काय ते equation मग? What will be equation? N2 by N1 into N4 by N3 is equal to D1 by D2 into D3 by D4. Write on this equation. Okay. Now we know that when one shaft, if we see the intermediate shaft or the middle shaft on which two pulleys are mounted. So what about the speed? Is it same or different for both the pulleys? Pulley number 2nd and pulley number 3rd. Whether speed is same or different? Same. So can we say N2 equal to N3? Yes. Right on. We know that we have as two pulleys are mounted on one shaft, next line, therefore N2 is equal to N3. मग ते इक्वेशन मध्ये सबस्टिट्यूट करा. म्हणजे इक्वेशन तुमचं आले की नाही? N2 by N1 into N4 by N3 is equal to D1 by D2 into D3 by D4. आले का? मग तिथं त्या N2 च्या ठिकाणी टाकून द्या व्हॅल्यू. काय आली? N3 get cancelled. So what is the equation? N4 by N1 is equal to D1 by D2 into D3 by D4. Yes. बघा तुमच्याकडे जर 4 पुलीज अवेलेबल असतील तर how we write the equation for the velocity ratio? You can say N4 by N1 is equal to D1 by D2 into D3 by D4. Similarly, if there are 6 pulleys, तर 6 पुली असतील, 8 पुली असतील, तर कसं लिहिणार इक्वेशन? लिहा ना मग. For 6 pulleys. N6 by N1 is equal to D1 by D2 into D3 by D4 into D5 by D6. Make the bracket, square bracket. Not square, rectangular bracket. Okay. कसा स्पीड रेशो काढायचा किंवा वेलोसिटी रेशो काढायचा. So using these equations we can determine the speed ratios or velocity ratios. Next point, power transmitted by the belt. Next point is for our discussion, power transmitted by the belt. Power transmitted by the belt. Okay, if there is arrangement of open belt drive or the cross belt drive, so how will calculate the amount of power transmitted by the particular belt drive? Okay, if you are considering the open belt drive arrangement, how much is the amount of power transmitted? If you are considering the cross belt drive, how much is the amount of power transmitted? Okay, so we'll have to get one equation. That equation is called as amount of power transmitted. Okay, so if you see the arrangement here, it is considered open belt drive where two pulleys are there. Both the pulleys are rotating in the same direction, and this lower portion where tension is higher, we can call as a tight side. Upper side, that is a slack side where the tension is lesser, we are calling as a T2. Okay, so based on this we have to calculate the power. So what is power? Work done divided by time. We have standard formula of power, work done divided by time. Now to get the work done, what is work done formula from the mechanics point of view? Force into displacement. So here force is nothing but what? Tension. That is called as effective tension. Whatever the initial tension, that is T1, then it is upper side tension T2. So we can say it is a effective driving force. Effective driving force is what? T1 minus T2. Getting? We are considering the overall for that particular belt. T1 is the higher tension and T2 is the lower tension. So that is what the effective driving force. So just note down. Effective driving force is equal to T1 minus T2. T1 minus T2. Next line, we have power is equal to work done divided by time. Power is equal to work done divided by time. Work done divided by time. आता work done काय येणार मग? Force into displacement. बघा आपण how we are making the equation power transmission चा. आता ती force म्हणजे काय? Effective driving force. त्याची काय व्हॅल्यू आली आपली? T1 minus T2 into displacement divided by time. Displacement divided by time म्हणजे काय असतं? Velocity असतो. Can we write T1 minus T2 into V directly? Write down. T1 minus T2 into V. T1 minus T2 into V. So tension is taken in considering Newton. Okay. तुम्ही मेकॅनिक्स मध्ये शिकला असाल. डायनामिक्स. न्यूटन किंवा पहिला चॅप्टर जो आहे इक्विलिब्रियम त्यामध्ये शिकला असाल तुम्ही. केबल मधलं टेन्शन वगैरे. It is in Newton into velocity. Okay, velocity in meter per second. That is what? Newton meter per second. It is what? Joule per second. When I say Newton meter means what? Joule. And then divided by second. That is what? Joule per second means what? Watt, na? Power is measured in watt or kilowatt. Okay. Then final equation, power is equal to T1 minus T2 into V watt. Power P is equal to T1 minus T2 into V watt. Make the rectangular bracket. जर तुम्हाला विचारलं ओपन बेल्ट ड्राइव अरेंजमेंट आहे क्रॉस बेल्ट ड्राइव अरेंजमेंट त्याचं तुम्हाला पॉवर ट्रान्समिशन काढा म्हटलं तर तुमच्याकडे जर टेन्शन T1 असेल, T2 असेल आणि वेलॉसिटी जर असेल तुमच्याकडे, तर तुम्ही यू कॅन सबस्टिट्यूट इन द फॉर्म्युला पॉवर P इज इक्वल टू T1 मायनस T2 इंटू वेलॉसिटी. असा तुम्हाला MCQ मध्ये प्रश्न विचारला जाईल. If a open belt drive arrangement consisting of following parameters, diameter they will give, speed they will give, tensions they will give, and we have to calculate the amount of power transmitted from that particular arrangement. This is the example. The example वरती तुम्हाला MCQ विचारतात. So you should be ready. Next, noted this equation. Okay. So this is the end of a belt drive. Belt drive chapter आता इथं आपला संपलेला आहे. Now we'll move to the next type of drive, that is called as chain drive. Put the heading. Chain drive. Everybody has seen the chain. काय काय असतं चेन मध्ये? चेन ड्राइव्ह बघितलाय का? सायकल मध्ये असते. ते जे असतात ते काय म्हणतात, दोन व्हील्स असतात त्यावर चेन बसले असतात, त्यांना काय म्हणतात? फ्री व्हील. ते आतमध्ये असते, पण त्याच्यावर काय असते? दात्र्यात असते. त्याला काय म्हणतात? त्याला मराठीत तुम्ही दात्र्या म्हणताय की नाही, गावाकडचा शब्द आपला. व्हॉट इज दॅट? जसं ते मडगाड असते, त्याला आपण काय म्हणतो? मडगाड. तसं आता जर तुम्ही असं जर बोलला गावामध्ये, काय म्हणतील? कसली इंजिनिअरिंग करता तुम्ही? यू डोंट नो द टेक्निकल वर्ड. यू आर टेक्निकल पर्सन अँड यू डोंट नो द करेक्ट वर्ड. बघा, हे सुद्धा गरजेचं आहे. म्हणजे मेकॅनिकल इंजिनिअरिंग तुमची जर डिग्री नसेल, पण तुम्हाला हे माहित पाहिजे, यू आर द टेक्निकल पर्सन. ऍटलीस्ट पार्टची नावं तर माहित पाहिजेत की जे तुम्ही वापरता दररोज. लक्षात. त्यामुळं एव्हरी इंजिनियर, व्हाय इन एव्हरी ऑल द युनिव्हर्सिटीज they are including the mechanical subject, civil subject, electrical subject for all the students. That is only this. They must know the basic things. प्रत्येक गोष्टीचं बेसिक थिंग माहित पाहिजे. तर या चेन ड्राइव्ह मध्ये तुम्ही बघितलं असेल की ते जे दोन व्हील्स असतात त्याच्यावरती ज्या टीथ्स असतात बघा, अशा ते स्प्रॉकेट्स आहेत. Those are called as sprockets, and though on that sprocket we are placing the chain. मग ती चेन जी असते ते काय असते, कसं तयार झाले असते, कशी तयार केली असते, कशी बनवली असते? ते लिंक्स असतात का नाही, वेगळ्या लिंक्स असतात. त्या लिंक्स तुम्ही काय करता, पिनच्या माध्यमातून ते जॉईन करता. And whatever the chain is there, it is of hardened steel. I'm using the word hardened steel. Hardened म्हणजे काय? त्याच्यावरती हीट ट्रीटमेंट करून जे काय बघा दिसतं बघा, चेन. चेन कधी अशी पांढरी दिसली की तुम्हाला? नेहमी काळपट असते. ते काळपट म्हणजे काय झाले, त्याला हार्डन स्टील म्हणजे त्याच्यावरती हीट ट्रीटमेंट केलेले, त्याच्यामध्ये कार्बोरायझिंग प्रोसेस कॅरी आउट केलेली. आणि कार्बोरायझिंग म्हणजे काय? adding the carbon deposition of carbon into surface of steel, that is called as carburizing. पुढे तुम्हाला एक मेटलर्जी म्हणून विषय आहे मेकॅनिकल. त्या मेटलर्जी मध्ये एक प्रोसेस आहे कार्बोरायझिंग प्रोसेस, नायट्रायडिंग प्रोसेस, सायनायडिंग प्रोसेस, अशा वेगळ्या प्रोसेस असतात. त्या प्रोसेस मध्ये हीट ट्रीटमेंट करायचं, हीट ट्रीटमेंट करून ते पार्ट हार्ड करायचा आणि हार्ड करून तो मग परत ऍप्लिकेशन देण्याचा. मग कुठले जे काय कुठला एखादा पार्ट काळपट दिसला विदाउट कलर अप्लाय करतात, ते म्हणायचं की इट इज अ हार्डन्ड मटेरियल. दॅट इज मीन्स व्हॉट? हीट ट्रीटमेंट इज कॅरीड ऑन दॅट पार्ट. त्याच्यावरती हीट ट्रीटमेंट झालेलं आहे, तेव्हाच ते काळपट होते. So that is the chain is of hardened steel material. Now here if you see the diagram of this chain drive, so there are chain links. Okay, links आहेत. Then these are the hinges. त्याला तुम्ही hinges म्हणू शकता. Okay, hinge केले आहे त्या ठिकाणी. Then this is a larger sprocket. जे मोठा आहे त्याला larger sprocket, or you can say gear. Then this is a smaller pocket, you can call as a pinion. So this is the arrangement you can find in the most of the agriculture machineries. Okay, जे agriculture machinery असतात ना किंवा automobiles तुम्हाला chain बघायला मिळते. Yes, you can find in such applications where it is used for transmitting the power from one place to another place. Now, what are the advantages of the chain drive if you compare with the belt drives? काय काय असले advantages? If you compare with the belt drives, ऐकाय ना मला काय म्हणतात. Strong, yes. The strength of this chain is more than that of the belts. Okay, this is one advantage. Azun, yes, it can transmit. आता आपण असं म्हणू की it can transmit large amount of power, or you can say it has high transmission efficiency. It has high transmission efficiency than that of the belts. Okay, this is also one advantage we can say. Next, advantage disadvantage म्हणजे काय झालं? Comparison. बघा दोन प्रश्न तुम्ही सॉल्व केले होते. Give the difference between belt drive and chain drive, and give the advantage and disadvantage of the belt drive and chain drive. झाले तयार तुमचे. क्वेश्चन विचार जातील. Which element gives high transmission efficiency? आधी पहिला ऑप्शन सांगू द्या. बेल्ट ड्राइव, चेन ड्राइव. ऑप्शन सी बेल्ट अँड चेन, अँड डी नन ऑफ दिस चेन ड्राइव. म्हणजे काही एमसीक्यू तयार करायला अवघड लक्षात ठेवायचं. पुस्तकात आहे तसं उचलावं असं काही नाही. Those are experienced teachers, they can create the questions. चेन ड्राइव मध्ये येस, म्हणून ग्रीप जास्त असल्यामुळे ट्रान्समिशन इफेक्ट चांगली. तर असं म्हणा वाटतं. ठीक आहे, there's a good more grip is observed in the chain drives, less grip in the belt drive. पण अजून काय सांगता येईल? नो स्लिपेज. नो स्लिपेज म्हणजे SLIPAG स्लिपेज, SLEEP लिहिणार. असा जेव्हा शब्द सांगतो ना असं ऑब्झर्व झाले पेपर चेक करताना. स्लिपेज, नो स्लिपेज इज ऑब्झर्व इन द चेन ड्राइव्स. ओके, असे तुम्ही कंपॅरेटिव्ह पॉइंट्स या ठिकाणी एक्सप्रेस करू शकता रिलेटेड टू द चेन ड्राइव्स. फास्ट फिरणार की मग शेवटी याला काय तर ऍडव्हान्टेज आहेतच ना. कॉस्ट बघा, कॉस्ट ऑफ द चेन ड्राइव्ह इज हायर दॅन दॅट ऑफ द बेल्ट ड्राइव्ह. गोळ्या कुठे असतील? त्याला ते गोळ्या म्हणतात, त्याला म्हणतात बॉल. सो दॅट इज व्हॉट ते ऍक्च्युअली ते प्रिव्हील मध्ये असतं. ते आतल्या बाजूला असतो ना, ती मगाशी म्हटल्यासारखं त्याच्यावरती असे टिप्स असतात, त्याच्या आतमध्ये फ्रीव्हील असतो आणि त्याच्यामध्ये आतमध्ये हे असतं तुम्ही म्हटल्यासारखं गोळ्या. आणि ते म्हणजे ते फ्रीव्हीलला असं इझिली फिरण्यासाठी केलेलं असतं. तशा टेक्निकल वर्ड फ्रीव्हील ना, फ्रीव्हील असेंब्ली म्हणायचं. गोळ्याच म्हटलं की बॉल. ते छोटे छोटे असतात ना, ते पूर्णपणे त्या पेरिफेरीवरती असतात ना, ते त्याच्यामध्ये ग्रेस वगैरे टाकून आपण हे करत असतो. आता स्पेसिफिक त्याची साईज वगैरे असते ना, ते किंवा त्याला तुम्हाला कंबाईन शब्द पाहिजे किंवा त्याला तुम्ही म्हणजे परफेक्ट टेक्निकल वर्ड त्या पूर्ण ह्याला प्रिव्हिलला दिसते त्याला काय म्हणू दुसरं काय म्हणू. तुमचा प्रश्न असा आहे की ते का टाकलं जातं, हा बरोबर आहे. ते बॉल्स का तिथं पुटअप केले जातात. मग बघायला पाहिजे. आय विल चेक आणि आय विल चेक. ठीक आहे. सो फॉर युअर अंडरस्टँडिंग यू प्लीज ड्रॉ दिस डायग्राम. We have very best tool that you can Google search. If you are not knowing, then we can Google search. Huh? काय म्हणतात? झालं. रॅचेट मेकॅनिझम रॅचेट रॅचेट हा RATCH रॅचेट मेकॅनिझम आहे ते. म्हणजे ते काय होत असते, आता आपण जे डायरेक्शन असते ना, एकाच डिरेक्शन ते होत असते मूव ना, दोन डिरेक्शन फिरत नसते. इट अलाउज ओनली वन डिरेक्शन टू मूव. Or now next, so then this question may be in our mind, what are the different types of chains? What are the different types of chains? Basically, three categories are there for the chains. One is hoisting chain, second is conveyor chain, and power transmission chain. Okay, so these are the three important types that we can find in the most of the applications. So hoisting chain means what? So that this is a roller kind of chain. Okay, you can see easily. So in the hoisting chain, basically it's a hoisting is a one mechanical device. It is a mechanical device which lift the heavy loads whenever you want to pick up the heavy loads and drop it some other places. So we are using the hoisting device, HOISTING, hoisting device. So where you can find the chains of oval shape. Oval shape chain. Oval shape. ओव्हल टाइप म्हणजे असं ते जॉईन केलं लिंक जे असतात ना, त्या ओव्हल टाइप असे एकमेकाला कनेक्ट केले जात असतात. So whenever the material is heavy type, that we are using this kind of chain for lifting the material or the lowering at the required place, lifting and lowering purpose. Then conveyor chain. So whenever there's a movement of material from one place to another place, we are using the conveyor systems. In the conveyor also we can go for the belt drive arrangement as well as chain drive also. Okay, so there's a conveyor chain. We can prefer this. Normally a roller type of chain or the rollers are will be there in the conveyor system. Then last is the power transmission chain. So power transmission chain means what? If you want to have the silent operation, जी काही chain तुम्ही use कराल, ते तुम्हाला operation perform करताना smooth आणि silent हवा असेल तर we can use this power transmission chain. Okay, simply you should know the types of chains in detail. You are going to study in the theory of machine. Okay. Just note down chain drive first of all. Chain drive is used for transmitting power. Chain drive is used for transmitting power from one shaft to another shaft. From one shaft to another shaft. At moderate distance. At moderate distance. At moderate distance. Okay. Next, it consists of three types of chains. It consists of three types of chains. Hoisting chain, HOISTING, hoisting chain. Second, conveyor chain. The third, power transmission chain. Okay, we have studied the advantages, disadvantage of the chain drive and the chain drive. Okay, there are certain disadvantages. Compulsory require lubrication, but it is not observed in the belt drives. So this is one disadvantage. For the maintenance purpose, maintenance is required in case of chain drives. So on time to time basis, lubrication is required. Proper alignment, adjustment is required. Okay. The production cost, you can say production cost of the chain is also very high. So this is what the advantage and disadvantage you can mention, or comparison we can mention between belt drive and the chain drive. Okay. So question on this you can write for the assignment. Give the difference between belt drive and chain drive. This is third question. No? Give the difference between belt drive and chain drive. Now next, last type of the drive, that is gear drive. So please put the heading gear drive. Anybody has seen the gear? Gear बघितलं का सगळ्यांनी? कसं असतं ते? एक गिअर ब्लँक असतो, त्याच्यावर टीथ कट केले असतात, बरोबर? अँड दोज टीथ्स ते कट कसे केले जातात माहिती आहे? एनीवन नोज द प्रोसेस? तुम्हाला माहित आहे? असणार आहे माहित. Because the teeth are cut on the one hobbing machine. There is a one hobbing machine on this. It is also called as hobbing operation. So gear hobbing we can carry out for doing or cutting the teeth on the gear blank. That is why it is one of the complicated part of the manufacturing. It is one of the complicated for the design. So gears are very difficult and complicated to manufacture as well as designing. So that is why there is a tremendous scope. Those who want to work in the gear industries, there's a tremendous scope to grow and earn the highest packages, good packages. Okay, because there are so many challenging tasks, so many challenging works you can find in the gear industries. There's a lot of rejection. Rejection percent in the gear industry is more. थोड़ा जर टीथ तुटला तरी सुद्धा काय डायरेक्ट स्क्रॅप असतं. Whenever you do the assembly of gears, okay, because that we are using for transmitting power. If gear is not proper up to the dimension or whatever drawing is prepared, so that gear will not be accepted. It will be kept in the rejection bucket. So that is why for the production engineer, those who will work in the production department, so they have very much big challenge if you get appointed to work in the gear industries. That is why I said there's a tremendous scope for your growth in the gear industries. So basically, it is complicated. Even if you look, यू फील समथिंग क्रिएटिव्हिटी, कसे टीथ कट केले असते, तुमची उत्सुकता वाढते. So to cut the teeth, there are so many parameters, so many critical parameters are there in the gears for manufacturing the gear teeth. म्हणजे असं लावलाय आणि ते कट केले असं नाहीये. We have to do the programming. There are high advanced machineries. On those high advanced machineries, we are preparing the programming of the how to cut the gears and number of teeth that you want to cut. Then later on, setting on the machine. जसं तुम्ही बघितलं लेथ मशीन वरती सरांनी सांगितलं तुम्हाला की एखादा वर्कपीस असेल त्या चेक मध्ये फिट करायचा, परत त्याला ट्रू करायचा. जर ट्रू केला तर त्याचं ते अॅक्युरेसी येणार आहे चांगली. जर ते थोडासा जर रनआउट असला जास्त तर टूल पण लवकर डॅश बसणार, तुटून जाणार आणि जो काही कॉम्पोनंट फिनिशिंग होईल तो कॉम्पोनंट पण अॅक्युरेट नसणार. सो दॅट इट इज डिफिकल्ट. ते हे जे आहे हा गिअरला पण तुम्हाला कट करत असताना प्रॉपर सेटिंग करावं लागतं. जो काही हॉब असेल तर हॉबला व्यवस्थित अँगल द्यावा लागतो आणि जो काही गिअर ब्लँक आहे तो गिअर ब्लँक प्रॉपरली फिट क्लॅम्प केलाय का, त्याचा रनआउट किती आहे वगैरे, या सगळ्या गोष्टी सेटिंग मध्ये इन्क्लूड होत असतात. तर ते प्रॉपर केल्यानंतर आपण ऍक्च्युअल गिअर कटिंग स्टार्ट करतो. सो आय विल प्ले वन व्हिडिओ रिलेटेड टू गिअर. यू विल कम टू नो हाऊ इट इज कॉम्प्लिकेटेड अँड हाऊ इट इज इम्पॉर्टंट. Just give me 1 minute. Is it visible? बघा हे जे इकडे आहे ते गिअर हॉब आहे आणि हा गिअर ब्लँक आहे. So there's one machine which is very much advanced. Okay, if you go in the gear industries, there's one machine you'll find that is Librer gear hobbing machine. On this machine, you can do the gear cutting that we'll see through the video. And here on this machine, not only skilled, high skilled operators are required. And those are the graduate engineers. Okay, they are not allowing diploma, they are not allowing IT holders. Okay, it's very high precise machine, we can say, highly precise machine where you can watch. This is the hub. हा हब आहे, हा गियर ब्लँक आहे. आता एकदा गिअर टीथ कट झाले की परत त्याला काय करायचं, ही ट्रीटमेंट करायची, हार्डर करायचं आणि नंतर मग असेंबली. एकदा टीथ कट झाले त्यातनं बर असतात बर किंवा एक्झॅक्टली मध्ये प्रॉपर मटेरियल कट होत नाही. सो दॅट्स वन मोर ऑपरेशन दॅट इज कॉल्ड एज गिअर शेविंग. I got appointed to work on this machine when I was in industry. बघा त्याला कट okay, got it, how the gear cutting. Now in this gear there are again different types of gears are there. We can manufacture accordingly on this such kind of machines. Okay, so we will see the classification of different types of gear based on various factors. Okay, so types of gears, basically it is classified into based on axis of the shaft, position of axis of the shaft. First is parallel, then second is intersecting, and third is non-parallel, non-intersecting shafts. Okay, based on the arrangement of a shaft or the position of the shaft, the gears are classified. If the shafts are parallel, so in that case you will find the three types of gears. One is spur gear, second is helical gear, and third is rack and pinion gear. Okay, then if the arrangement of shaft is intersecting, intersecting means what? What are the shafts are there? Two shafts. Okay, so those shafts are intersecting at 90-degree angle. So for this case, you can study a BVL gear. So BVL gear is the one gear where the shafts are intersecting. Then last is non-parallel, non-intersecting. So where we'll cover worm and worm gear. Okay. So all these types we will study in detail. So there are very much complicated diagrams to draw this. We'll have to give some time, but that diagram part will be drawn in 3 to 4 lecture. Okay, so just we'll discuss, but I think one diagram we can draw it easily. That is the diagram for the spur gear. Okay, so this spur gear ची आपण diagram काढू आणि नंतर बाकीचे जे gears आहेत त्याचं फक्त explanation आपण discuss करू आणि diagram will be drawn 3 to 4 combined divisions when we combine the division behind. So please put the heading gear. Gear, you can have the definition. Gear is a wheel. Gear is a wheel. Gear is a wheel on which teeth are cut. Gear is a wheel on which teeth are cut. Gear is a wheel on which teeth are cut. By hobbing process. By hobbing process. HOBBING, hobbing. By hobbing process. Next line. Types of gears. Types of gears. Next heading will be types of gears. So these types of gears are based on axis of the shaft. position of axis of the shaft. Write down. According to the position of axis of the shafts. According to the position of axis of the shaft. Axis of the shaft. त्याच्यामध्ये स्मॉल a म्हणा, parallel, in that 3 types of gears: spur gear, helical gear, then rack and pinion. Spur gear, helical gear, and third is rack and pinion. Rack and pinion. Then small b, intersecting. 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 In the intersecting, we'll study bevel gear. Bevel gear. And last is non-intersecting and non-parallel. So we study worm and worm gear. Worm and worm gear. Okay, now we'll see one by one. First is spur gear. Please put the heading spur gear. Now look at the picture. What is your observation? You can see the animation also. What is your observation? Both the gears are meshing each other and rotating in a opposite direction. Okay, this is one. And second, spur gear teeth are cut straight. This is straight. Top baga. Teeth are cut straight. So spur gears are having the teeth straight, and this kind of gear is used for transmitting the power from one shaft to another shaft when the shafts are arranged parallel. Okay, so where this spur gear you'll find most of in the automobile sector, automobile vehicles, or we can say in the watches, clocks, washing machines, then oscillating sprinklers. Everywhere you will find in all the machineries spur gear arrangement you will find. प्रत्येक ठिकाणी तुम्हाला spur gear हा बघायला मिळेल everywhere. So in the spur gear, whenever the two gear get meshes with each other, there is a line contact. There is a line contact. When there is a line contact, then it will create noise. ज्यावेळेस gear असा mesh होतो की नाही, असा खट असा आवाज येतो. So it will create noise. That is why it is not much used in the power transmission, maximum amount of power transmission. ज्यावेळी तुम्हाला maximum amount of power transmission जर करायचे असेल, we are not using this spur gear. Okay, so reason is it creating the noise. Okay, so it will be used for transmitting the lesser amount of power as compared to the other helical gear. Okay, after this there is a helical gear that we can study it. Have you got it? Spur gear. Spur gear म्हटलं का त्याचे टीथ कशा असतात, स्ट्रेट असतात, आणि याच्यामध्ये ज्यावेळेस त्याचं मेशिंग होत आहे, ज्यावेळेस दोन गिअर त्यावेळेस ट्रान्समिशन चालू होतं, त्यावेळेस एक गिअर हा क्लॉकवाइज फिरतो, दुसरा अँटी क्लॉकवाइज. अकॉर्डिंगली दी पॉवर ट्रान्समिशन happens. Then this is areas we can find in automobile sectors, automobile vehicles, then clocks, washing machine, clothes dryers. These are the applications. There are many applications we can find this spur gear. Even you can see in the sugarcane crusher, there is also one spur. What are the gears you have seen? there are the spur gears, and you can find there is a line contact. Due to the line contact, it create noise. It is noisy gear. It will create a noise. That's why it is noisy gear. Then next gear is helical gear. Just see the helical gear, how it is. What is the change? Why it is named as helical gear? Helix angle. There's a certain angle is given here. दिसतोय का? ते तुम्ही दोन गिअर इथं दाखवते बघा पिक्चर मध्ये. असे टीथ थोडेसे इन्क्लाइन दिसतात आहे की नाही? This is what helix. Helix angle is given. Angle is given to this teeth. That's why it is called as helical gear. Now this helical gear is used for transmitting the large amount of power. Whenever you want to transmit the large amount of power, because it perform very smooth and silent operation. म्हणजे ज्यावेळेस ते दोन गिअर मेश होतात त्यावेळेस पहिला सुरुवातीला तिथं पॉइंट कॉन्टॅक्ट होतात. पॉइंट कॉन्टॅक्ट हळूहळू ते मेश होते. This process is happening very smoothly. That is why in the automobile vehicles this gear is used more. म्हणजे कसं असतं की ज्यावेळेस गिअर बॉक्स तयार होत असतो त्यावेळेस नंबर ऑफ गिअर्स असतात. येते लक्षात? नंबर ऑफ गिअर्स असे जोडले असतात, मेश केलेले असतात. तर त्याच्यामध्ये हेलिकल गिअरची संख्या जास्त असते. मेन ॲडव्हांटेज इज दॅट इट विल बी युजफुल फॉर ट्रान्समिटिंग दी लार्जर अमाउंट ऑफ power, and here you can find there is a line contact. There is a line contact. Sorry, point contact, not line contact. Line contact is observed in the spur gear, and this helical gear there is a point contact. हा तुम्ही डिफरन्स सांगू शकता. हेलिकल गिअर मध्ये फरक काय, लाइन स्पर गिअर मध्ये काय फरक आहे? You can tell this. Teeth are straight. Helical gear मध्ये teeth are inclined with certain angle. त्यानंतर इथं तिकडं लाइन कॉन्टॅक्ट, इकडं पॉइंट कॉन्टॅक्ट. हा बेसिक डिफरन्स तुम्ही सांगू शकता. Is it clear at all? Helical gear. Next, third gear is rack and pinion gear. Rack and pinion gear. So what is the purpose of using this rack and pinion? Whenever you want to convert rotary motion, see, रोटरी मोशनचं तुम्हाला जर लिनियर मोशन मध्ये कन्वर्जन करायचं असेल, वी कॅन यूज दिस रॅक अँड पिनियन मेकॅनिझम. जसं आपण 4 व्हीलर्स मध्ये बघितलं, येतं ते स्टेअरिंग असतं ना, स्टेअरिंगची तिथं रॅक अँड पिनियन मेकॅनिझम. आता तुम्हाला ज्यावेळेस तुम्ही लंच ब्रेक मध्ये किंवा सोमवारी आल्यानंतर यू कॅन टेक राउंड टू आवर वर्कशॉप वन्स अगेन, and in workshop immediate after entry you go to left side, there is a one automobile engineering lab. In automobile engineering lab, there are all the equipments related to the vehicles. There is a steering system. There is a one different power transmitting elements are there. Gears, chains. Then one two-wheeler is there. It is model, we can say. Again, compound. There's differential gearbox. You can find differential gearbox. असे खूप सारे ऑटोमोबाईल रिलेटेड इक्विपमेंट्स आहेत, त्याच्यातून तुम्हाला स्वतः बघता येईल काय काय पार्ट्स आहेत त्यामध्ये. तर हा रॅक अँड पिनियन तुम्हाला स्टेअरिंग मध्ये बघायला मिळेल. सो दिस रॅक अँड पिनियन मेकॅनिझम विल बी युज्ड फॉर कन्वर्टिंग रोटरी मोशन इनटू लिनियर मोशन. जर तुम्हाला कन्वर्जन करायचं असेल मोशनचं तर वी कॅन प्रेफर दिस रॅक अँड पिनियन मेकॅनिझम. Then bevel gear. So this gear comes under which category? What is the arrangement of shaft? Intersecting. Yes. आता ह्याच्यावर तुम्हाला एमसीक्यू विचारला जातो. When shafts are arranged parallel, when shafts are intersecting at certain angle, which gear is preferred? Spur gear, helical gear, bevel gear, rack and pinion. काय म्हटलं मी? When shafts are intersecting at certain angle 90 degree, then which gear is preferred? bevel gear, spur gear, rack and pinion, आणि कुठला bevel सांगितलंय? बिव्हेल गिअर, रॅक अँड पिनियन, स्पर गिअर, हेलिकल गिअर. कुठला? बिव्हेल गिअर. बिव्हेल गिअर हा आपण बघ ना क्लासिफिकेशन मध्ये. बिव्हेल गिअर, you can see the arrangement of shaft is intersecting. Means what? You just see the diagram. So the diagram you'll understand. Baga. So there are two types of gears in the bevel gear. So there's a straight bevel gear. म्हणजे teeth are cut straight. That is why it is called as straight bevel gear. And here the teeth are cut inclined. That is called as spiral. Spiral type of bevel gear. Spiral cutting केलेलं. So, and what are the shafts are there? You can pass the shaft from here and vertical shaft. So it is intersecting at 90-degree angle. Barabar? So this straight and spiral gears can be used in the differential gearbox. कुठे वापरतात ते? Differential gearbox. Differential gearbox कुठे असतो? जे ट्रक्स वगैरे पाहिलेत का तुम्ही? खालच्या बॉटम साइडला एक मोठा हब असतो बघा. आणि जे काही प्रोपेलर शाफ्ट आहे तिथून जी पॉवर मिळणार आहे प्रोपेलर शाफ्ट द्वारे. So that will be divided to the rear wheels using differential gearbox. In the differential gearbox, this gear is present. बघा, जो काही differential gearbox आहे त्याच्यामध्ये हा bevel gear present. And by using this bevel gear, we are distributing the speed to the rear wheels. And accordingly, the vehicle is moving ahead. येते लक्षात. So you should know where the bevel gear is used. It is used in differential gearbox. Clear? Then last gear is worm and worm gear. Worm and worm gear. So this gear is used whenever you want to have the large speed reduction. तुम्हाला खूप सारं स्पीड कमी करायचं. फॉर एक्झाम्पल लेथ मशीन. लेथ मशीन मध्ये तुम्हाला एक टॅपिंग ऑपरेशन करायचं, थ्रेडिंग करायचं. You need to have very less speed. खूप कमी स्पीड पाहिजे. So we have to go for the worm and worm gear arrangement. म्हणजे तिथे worm and worm gear arrangement incorporate केलेला आहे लक्षात ठेवा मशीन. We have to go for the making arrangement only. Gear train फक्त त्याप्रमाणे सिलेक्ट करायचं. So this worm and worm gear is used when there's a large gear reduction is required, speed reduction is required. We can select the worm and worm gear. So normally you can find in the machineries. Okay, for example, lathe machine or the any other machineries. So this is the worm and worm. Baga, shafts are non-parallel, non-intersecting. Definitely तुम्हाला MCQ असा प्रश्न विचारणार लक्षात ठेवा. शाफ्टच्या अरेंजमेंट वरून तुम्हाला टाइप ऑफ गिअर सिलेक्ट करायचं लक्षात ठेवा. येते लक्षात. किंवा तुम्हाला गिअरचं नाव सांगतील आणि तुम्हाला शाफ्टचं नाव सांगायचं, पोझिशन ऑफ शाफ्ट सांगायचं. कळतंय का? गिअरचं नाव तुम्हाला सांगतील फॉर वर्म गिअर, पोझिशन ऑफ शाफ्ट प्रेफर्ड, नॉन पॅरल, नॉन इंटरसेक्टिंग, इंटरसेक्टिंग अँड पॅरल. नन ऑफ द अबव. नॉन पॅरल, नॉन इंटरसेक्टिंग. हे पटकन तुम्हाला ऑप्शन सिलेक्ट करता येईल. सो दिस इज द worm and worm gear. The next point is types of gear trains. Please put the heading. Types of gear trains. Types of gear trains. Types of gear trains. First is simple gear train. Simple gear train. Second, compound gear train. Third is epicyclic gear train. So तीन टाइपची gear trains लक्षात ठेवा. Epicyclic gear train. EPICYCLIC. Cyclic. Epicyclic. EPICYCLIC. Epicyclic gear train. आता पहिला टाइप बघूया आपण मग. सिंपल गिअर ट्रेन. सिंपल गिअर ट्रेन म्हणजे काय? एका शाफ्ट वरती एकच गिअर आणि मेशिंग करत जायचं. असे नंबर ऑफ गिअर जोडायचे. तुम्हाला एका पॉइंट पासून दुसऱ्या पॉइंट पर्यंत जर पॉवर ट्रान्समिट करायचं असेल फ्रॉम वन शाफ्ट टू अनदर शाफ्ट, इफ द डिस्टन्स इज समवॉट लार्जर, then we can select the number of gears together. असे 1 2 3 4 5 6 असे गिअर तुम्ही सिलेक्ट करायचे आणि दॅट इज व्हॉट यू कॅन कॉल एज अ गिअर ट्रेन. एक ट्रेन तयार झाली ना. व्हाय द नेम इज गिवन ट्रेन? नंबर ऑफ गिअर्स आर ऍडेड ओव्हर हिअर. इट लुक्स लाईक अ ट्रेन म्हणून त्याला काय म्हटले? गिअर ट्रेन. सिंपल गिअर ट्रेन. So for having the gear train, you can select any of the gears. You can have the spur gear train or helical gear train. Getting for transmitting the power from one shaft to another shaft. Getting. So can you draw this arrangement to understand the simple gear train? Right. There are 4 gears are there. You can see this arrangement in the lathe machine. तुम्हाला ज्यावेळेस मशीन टूल बघितलं, lathe machine बघितलं त्यावेळेस दाखवलं कसं आहे. Now in this simple gear train, the shafts are looking parallel to each other. Okay, and the gears are rotating accordingly the directions. One is clockwise, second is anti-clockwise. Driving gear, driven gear, driving gear, driven gear. So accordingly, the power get transmitted from one point to another point. Right. So you can select spur gear or you can select the helical gear. So such type of arrangement you can find in the machineries. You can, for example, lathe machine. It is there. The next is compound gear train. Put the heading compound gear train. In compound gear train, जसं तुम्ही बेल ड्राम मध्ये बघितलं कंपाऊंड बेल ड्राम, तसंच काय कंपाऊंड गिअर ट्रेन म्हणजे एका शाफ्ट वरती 2 गिअर्स माउंट करायचे. That is called as compound intermediate gears. So draw the arrangement of compound gear train. Compound gear train. Compound gear train. Okay, drawn. Now this compound gear train arrangement is used whenever you want to have the large speed reduction ratio. Okay, जर तुम्हाला speed reduction करायचं असेल larger level ला व high level ला, so we can select the compound belt drive, not belt drive, compound gear train arrangement. Belt drive चा late पडला, hammering झालं बरोबर. So compound gear train is preferred, or it is preferred when there is a requirement of large speed reduction ratio. Larger speed reduction ratio, we can select this compound gear train arrangement. Okay. So in this arrangement, if you see that one shaft, there are two gears are mounted, and accordingly the power is transmitted. Okay. Just note down one line in case of compound. It is used for obtaining large speed reduction ratio. Large speed reduction ratio. It is used for obtaining large speed reduction ratio. Large speed reduction ratio. Full stop. So this compound gear train arrangement you can find in our lathe machine also. आपल्या lathe machine मध्ये सुद्धा तुम्हाला compound gear train चे arrangement बघायला मिळेल. कारण का हे तुम्ही मला सारखं lathe machine का सांगायला लागला. कारण lathe ही असं मशीन आहे, it is called as universal machine, and on that machine we are performing number of operations. त्यामुळे हे आपल्याला अरेंजमेंट गरजेचं असतं, त्यामुळे आपण ते करत असतो. ज्या मशीन स्पेशल पर्पज म्हणजे एकच ऑपरेशन केलं जातं त्याला माझं स्पेशल पर्पज मशीन. एक ऑपरेशन केलं असं माझं स्पेशल पर्पज मशीन. But lathe is a universal machine on which number of operations are performed. So we need to incorporate, we need to add this kind of arrangements of the gears, compound gear train. Correct. Then and then only the speed reduction is possible. Okay. So you should know where it is compound gear train arrangement also used. Okay. Then we will see the nomenclature of the gears. आता गियर आपण बघितला पीक कट होते वगैरे वगैरे, पण त्याला काय काय म्हणलं जातं, ते प्रत्येक पोर्शनला काय म्हणलं जातं दॅट विल सी. बघा तुम्ही अगदी थर्ड इयर लेवलचा शिकायला हवा. ते पुढे आहे तुम्हाला डिटेल मध्ये, पण स्टील वी आर डिस्कसिंग नाउ. Is it visible? These are the nomenclature part, or you can say geometric parameters for the gears. बघा मी म्हटलं ना गियर हा खूप कॉम्प्लिकेटेड आहे. एवढे पॅरामीटर तुम्हाला मेंटेन करावं लागतात, तरच काय होते गियर स्मूथ वर्क करते, नाही तर करत नाही. आणि हे लक्षात ठेवा की सगळं मायक्रॉन मध्ये मेजरमेंट आहे. मायक्रॉन, नॉट mm ऑल्सो. All the dimensions are measured in micron. It is very much precise process of operation. Okay. So please put the heading nomenclature. Nomenclature of the spur gears. So after nomenclature, we'll have to draw one gear diagram. So I will draw on the board. Online. Now you can take it down. Huh? इसकी बात डाउन क्यों करें? ये डायग्राम का साइड से ठीक है खाली सर कौन गेट थोड़ा चाल हाँ not coming. Then if not coming, then I will inform you. They are coming here only. Yes. If they are not coming, then I will inform. Huh? I told them 3 to 4 come. Now, in this nomenclature, whatever the parameters that we have to control, or whatever the parameters that it is measured normally, that is fillet radius. You can see this is fillet. I am moving the cursor over here. This is called as fillet. This is fillet radius. Then this is flank. As a portion, fillet chavarcha. This is called as flank. Then from the center to this upper portion to the top point, this is called as face of the teeth. फेस ऑफ द टीथ, जे काय टीथ आहे गिअर टीथ त्याचा फेस आहे हा. त्याच्यानंतर फेस विड्थ, इथून ते इथपर्यंत जे डिस्टन्स आहे दिस इज कॉल्ड एज फेस विड्थ. सॉरी, हा पॉइंट टू हा पॉइंट, दिस इज टोटल फेस विड्थ. ओके, देन दिस इज, हे जे आहे इकडचं, आय एम मुव्हिंग कर्सर हियर, दिस इज कॉल्ड एज टूथ थिकनेस. Tooth thickness, right? Then next is one dotted center line is going from this teeth, from the center of the teeth, that is called as pitch circle. That is called as pitch circle, right? कारण एमसीक्यू मध्ये विचारतं सांगताला पाहिजे. The line which is passing through the center of the teeth, the line which is passing through the center of the teeth is known as pitch circle, addendum circle, dedendum circle, none of them. It is pitch circle. So here there are some names like addendum, dedendum. So dedendum means what? The distance between pitch circle and the bottom of the tooth. That is the dedendum. The terminology लक्षात ठेवा. Then from the pitch circle to the top of the teeth, it is called as addendum. Then whatever the circle is drawn from this top of the teeth, the top of the teeth पासून जे सर्कल जर काढलं, that is called as addendum circle. आणि बॉटम पासून जर आपण सर्कल काढलं, बॉटम ऑफ द टीथ पासून जर सर्कल काढलं, that is called as dedendum circle. Okay, then this is a clearance. Why this clearance is provided? Because there should be smooth meshing of the gears. If you are not providing the clearance or the there's one term, backlash and clearance. It is required thing for the proper meshing of the gear and the transmitting the power smoothly without any noisy operation, without any noise. Okay, so there must be a proper backlash and the clearance when the two gear get meshes with each other. Okay. So that is it is required, otherwise jamming will happen. ये दोन gears असे jam होते, फिरणार नाही, power transfer होणार. So to avoid such problems, that there's a provision of a clearance, etc. Then whatever the root circle, whatever the line passing from this bottom, it is also called as root circle. Okay. So these parameters you should know it. Whenever we design the gears, whenever we manufacture the gears, we consider these parameters are the important parameters, and those all the parameters are measured, and this is called as profile. बघा हा काय प्रोफाइल आहे. तुम्हाला ही कसं मोजायचं? So there is a one gear profile tester, व gear tooth profile tester. खास स्पेशल मशीन आहे लक्षात ठेवा, आणि खास त्याच्यासाठी एक वेगळं ट्रेनिंग असते त्या मशीन साठी, आणि त्यासाठी खास स्पेशल माणूस असतो कंपनीमध्ये. त्यामुळे ज्या विद्यार्थ्यांनी स्पेसिफिक असे ट्रेनिंग करतात त्यांना तशी जॉब मिळत असतात. गिअर टेस्टिंग मेजरमेंट जे असते प्रोसेस, ते तुम्हाला जर कॅरी आउट करायचं गिअर इंडस्ट्रीमध्ये, तर यू हॅव टू कम्प्लीट द कोर्सेस. सो दिस प्रोफाइल इज व्हेरी मच इम्पॉर्टंट. देयर शुड बी अ प्रॉपर प्रोफाइल is there, then only proper meshing of the gear will take place, and accordingly the power transmission will be carried out. Okay, so I hope that nomenclature part is clear, and the whatever the gear I have drawn, whenever if it is asked to draw this per gear, you can draw the gear like this, as a gear काढायचं. So I have brought some diagrams. We'll see, we'll take a break of 10 minutes, then we'll join back. सर्वांना कळालं नॉमेनक्लेचर काय असतं गिअर मध्ये? तर ह्याच्या नॉमेनक्लेचर वरती तुम्हाला प्रश्न विचारताच लिहिता येईल का? सर्वांना लिहिता येईल? आता कसं आहे म्हणा, ही सगळं बघितलं पण जो पण हातात गिअर येत नाही तो पण कळत नाही, हे खरं आहे. त्यासाठी तुम्ही वर्कशॉप मध्ये जावा. वर्कशॉप मध्ये ऑटोमोबाईल लॅब मध्ये पण गिअर्स असतील बघायला मिळतील तुम्हाला. प्लीज वॉच, प्लीज ऑब्झर्व इट. ठीक आहे. So we'll take a break of 10 minutes and we'll join through the division B link. Okay, I will send the division B link on this Telegram channel. On that link, everyone has to join, except the students who are offline. Okay, जे offline आहेत त्यांना काही compulsion नाहीये to join online only. But those who are attending from the home, so they have to join through that link. I will share on the Telegram channel.
Hello sir.
Yes.
Lecture upload करा ना.
हाँ, हे लेक्चर अपलोड कर. आपले 2-3 लेक्चर पेंडिंग आहे अपलोड करायचे ना.
हाँ सर.
ओके ओके. आज करून टाकतो. आज संपते सिलेबस त्यामुळे आज सगळे लेक्चर अपलोड करू. ठीक आहे. So attendance I will take at the last, no? After 4. Huh? So I want all to be present for that last lecture. So we'll conclude the meeting here. Thank you very much.